Hello everyone. In today's presentation, we will discuss some of the model question paper questions with related to module 2, that is the transmission characteristics of optical fiber, and also along with some of the different losses with respect to the or in terms of dispersion factors or the bending loss factor or the attenuations, losses, scattering loss, absorption loss, all these type which we already seen under the module 2, and with related to that, and from previous question paper I just taken the module 2 questions. So 3 and 4 that belongs to module 2, hence these are the questions which is asked in the previous last year question paper. So I'll just go through one by one, and we will discuss about these questions in this today's presentation. So coming to point, the question, first question here, that is 3a, explain the different absorption mechanism in optical fiber. So it is asked for 8 marks. So the mass distribution for 8 marks that can be taken for the absorption mechanism have to be identified. There are two categories basically. So you have to explain it. Two categories, split it up the absorption into 4 marks. So I think if you have a graph, you can draw it, and whatever the types, you can explain it. That is what the condition you can take it for 3a. I will discuss in briefly whatever we discussed in the presentations also. The same slide, I'll just show it to all these answers. Coming to the 3b, it is asked as linear and non-linear scattering losses in optical fiber. So we have two sets here. One is linear scattering loss have to be explained. Another one is non-linear scattering loss have to be explained. So coming to the question that which is having 8 marks, so 4 marks for linear, non-linear 4 marks. So we can distribute it into the two cases. So coming to the fourth set, we have the macro bending. First question is to explain macro bending and micro bending losses, which will be there under fiber bend loss. Asked for 6 marks, 3 you can distribute it. Fourth B, it is asked as a chromatic dispersion with an optical fiber, asked for 6 marks. So we just need to understand the concentration of the marks with respect to the chromatic distribution is 6, and the fourth C is a problem. So we'll discuss this problem in the further slides. So coming to the third A question. So it is material absorption loss. How we can explain it? So basically, what do you mean by material absorption loss? You can mention it. So what is the actual phenomenon under absorption? How it is going to be happen? So under that we have two types: intrinsic absorption and extrinsic absorption. What do you mean by intrinsic absorption? Which is caused because of the interaction of one or more major components of glass. Extrinsic absorption caused by the impurity within the glass. So the two absorption conditions because of two different natures of the optical fiber. So that also we can explain it with respect to this graph. This two particular absorption material conditions along with the material which is mentioned. So you can discuss about the absorption condition also under this particular question. So there is some table also we mentioned, but extrinsic loss mechanism is absorption due to water or dissolved in the glass, that particular content. Based on that, it is going to be actually happened. Okay, so coming to the next question, that is 3b, linear and non-linear scattering. So linear scattering, if in the sense, what do you mean by scattering loss? You can mention it a point. Along with that, we can also take it. So what do you mean by Rayleigh scattering? So what do you mean by that, and how it can be approachable with respect to the Rayleigh scattering? Same condition we have to take it for Mie scattering also. So the coming to the Rayleigh scattering, if I specify, so what do you mean by that? So it can be calculated. The loss we can calculate it for the Rayleigh scattering loss is in terms of exponential of minus gamma r into L is the length, how much we consider, based on that we can take it. But gamma r is nothing but it is Rayleigh scattering coefficient. So this coefficient can be calculated using this equation. Gamma r is equal to 8 pi cube divided by 3 lambda to the power 4 into n to the power 8 p square beta c k into tf, where the gamma r is the Rayleigh scattering coefficient, lambda is however optical wavelength, n is the refractive index of the medium, p is nothing but the average photoelastic coefficient, beta c is the isothermal compressibility at temperature, effective temperature tf, k is the Boltzmann constant. So Rayleigh scattering, if you take it, it is always proportionate to 1 by lambda to the power 4. So that is what the scattering coefficient term, which we can consider it under the linear scattering laws. So the explanation with respect to the Rayleigh scattering and also the Mie scattering also it is mentioned here. So the scattering created by inhomogeneities is mainly forward directions. We'll call it as a Mie scattering. Rayleigh scattering is the dominant intrinsic loss mechanism. Inhomogeneities is existed under that situation also. It is always proportionate to 1 by lambda to the power 4. So all these points which you can take it to explain about linear scattering laws. So the other part under the same question, that is for 3b, we have nonlinear scattering also. Under nonlinear scattering, what do you mean by that? It causes the optical power from one mode to transfer into either the forward or backward directions. In that manner, you can definitely define the nonlinear scattering loss. Later, there are two types. We can discuss about that. Stimulated Brillouin scattering, SBS, and SRS, that is stimulated Raman scattering. So there are two cases of nonlinear scattering, SBS and SRS. So in that, with respect to that, we can calculate the scattering process by producing a phonon PB with respect to the Brillouin scattering, that is PB. So we can take the equation corresponding to that. Coming to the SRS scattering, where we have PR, this is also we have as an experimental result conditions. So this 5.8 into 10 to the power 2 or 4.4, which is obtained after experimental result. They finalized with respect to the what is the acoustic phenomenon with respect to the Raman scattering or Brillouin scattering. So this is how they can explain it. We can explain it all linear and non-linear scattering laws. Coming to the fourth A question that belongs to macro bending and micro bending. So this is completely absolutely belongs to a bend loss. So if I take the bend loss, any curvy nature, we can take that particular condition. So under this particular bend loss, we can have a macro bending and micro bending. First, I will take it as a micro bending. So this is normally which is going to be happen in the curvature, where it is going to be happen. The micro bending will be taken place as the small amount of layer of light traveling. There will be a fluctuations, or there will be a traveling of light across the core cladding junction. So that is going to be wasted or lost in terms of that. This is a micro bending, or micro bending, because of that we can take it this kind of loss. So the radius of curvature with respect to this we can calculate using this equation, 3n1 square lambda divided by 4 pi into n1 square minus n2 square to the power 3 by 2. So this equation, radius of curvature for a given optical fiber under the it should be taken for the multimode, not only single mode or any other particular multimode conditions. So if suppose I use single mode, radius of curvature, we can calculate some modifications, lambda, which is going to become lambda c, that is the kind of critical angle or wavelength with respect to lambda c, which is mentioned under this equation. So these two equations to mention the radius of curvature, which we can calculate with respect to single mode and multi-mode conditions. So this we can use it under the micro bending, and also we can take it as some macro bending loss. Macro bending loss is in the sense that again the radii of the signal which is going to be changed. So that also gives some modifications under macro bending. So coming to the question number 4b, we have something a chromatic dispersion and intramodal dispersion which is mentioned. So intramodal dispersion under chromatic dispersion we can take this name also, intramodal dispersion. It is an the finite spectral line width of optical sources. So chromatic dispersion, we can also explain it under chromatic dispersion. First of all, what is chromatic dispersion? How it is going to be appear, this dispersion factor, and what are the difference changes with respect to chromatic also. Coming to this chromatic dispersion, we can majorly classify it into a material dispersion and also waveguide dispersion. The material dispersion, how the dispersive property of a waveguide material. So waveguide dispersion is because of guidance effect. So with all these two categories under material dispersion, we have something derivation to calculate the dispersion factor with respect to small changes with respect to material, which is mentioned in material dispersion. So we can also explain about that also under chromatic dispersion. If the question is asked for maximum mark, then we can go for the clean derivation for material dispersion also, because they are not mentioned much more about the waveguide dispersion. So we can much more elaborate on material dispersion. So if the question is asked with the chromatic dispersion, then I just certainly have to be explain about material dispersion and also waveguide dispersion. So these factors are going to be very important. So keep looking into the notes whatever we are provided with respect to the unit, and also you can look into the textbooks, soft copy textbook, into the derivations of the material dispersion also. Coming to the fourth C question, I said we have a problem. The problem statement is like this: when the mean optical power launched into an 8 kilometer length of a fiber is 120 microwatt, the mean optical power at the fiber output is zero point 0.3 microwatt. So determine what we have to determine overall signal attenuation or loss in decibel through the fiber, assuming that there are no connectors and splices. So if there is no connector, no splices, means there is no effect of that. Directly we can take it with respect to the attenuation loss, we can consider it. So signal attenuation loss, we can take it from the 10 log pi divided by p out, p input by p out. That is what power input power output ratio with the 10 log will give signal attenuation. So power in, we know the power launched for a 8 kilometer length of fiber. So launched means power is coming as 120 microwatt, but the fiber output is 0.3 microwatt. So P in is this 120 micro, P out is 0.3. If I take that ratio, so 120 by 0.3 along with the 10 log base 10 we have to consider. So if you simplify this, I'll get to 26 dB as the overall signal attenuation in decibel through the fiber over a distance. So the next part of the question is we have the signal attenuation per kilometer for the fiber. So signal attenuation is we have 26 dB over here. With respect to that, we have to calculate the signal attenuation per kilometer. So alpha dB into L is equal to 26 dB. So L is 8, that is what the given information. So L is 8, so 26 by 8 is 3.25 decibel per kilometer. It is an alpha dB, a signal attenuation factors per kilometer for the fiber. So this is how we can find the solution this particular problem. These are the few other questions which is purely goes into the previous schemes. So we'll discuss about the some of the questions under this. So explain the different types of attenuation in optical fiber. So you can discuss about the different attenuation factors, how we can take the attenuation or attenuation, how it is going to be done and how it is going to be defined. So second question here, it is derive an expression for the pulse spread due to the material dispersion using group delay. So the graph of under chromatic dispersion, or sorry, material dispersion, which comes under however material chromatic dispersion, where we taken the graphs which is overlapping. So that graph along with that the equation for a material dispersion pulse spread T spread equation we have to derive here. Along with that particular diagram also we can take it. So the last question is a step index fiber. So this is not belongs to actually for this particular module. So because of old scheme question paper which I just taken here, so this question is not there. And also in the second set also the old system questions, where the second question is not there with respect to the signal. Okay, this is there. So 12 kilometer with the loss is this much. Minimum optical power launched into the fiber is optical fiber level is 0.3 at the receiver end. So we have the loss value, we have length, we have the power output, we have to calculate power in. So what is the required input power if the fiber has a loss about loss change, then we can also calculate. So earlier whatever we problem solved, so same manner we can solve this particular question. So the other two questions are theoretical. So discuss the importance of the signal attenuation, explain the three minor mechanism which cause the absorption loss of optical energy in fiber. So the explain the different various types of chromatic dispersion which results from the finite spectral line width of the optical source. So here chromatic dispersion have to be explained with finite spectral line width, the graph which need to be mentioned. So this is all about the previous year question paper on regarding to the module 2, where we have to focus on to the attenuation factor and also loss and also the chromatic dispersion. Even fiber bend loss also going to be important, along with the dispersion parameter, and also the scattering parameter is also going to be important. Meanwhile we have to focus on to the problems what we have in the module 2 also, because each and every questions at least it may contains either 4 to 6 mark of one problem question which you can observe it as per the exam point of view. So please keep looking to the whatever the topic what we discussed under module 2, the respective videos however earlier we mentioned. If you have any doubt with respect to the any topic, so you can come up through WhatsApp or mail or direct call also you can make it, so that you can try to understand the concept very clearly for module 2, and you have to be able to replicate it in the examination in the proper manner. And thanks for listening. Keep a look and study all the concepts.